Okay, Assalamualaikum. This is a video to show how we make a Michaelis-Menten Vozeh plot. This is usually used for Phenytoin. When we have one steady state level and we want to find what is the Vmax, what is the Km, and perhaps with a CSS desired, we can actually find a new dose which will be parallel to the CPSS that we want. Okay, so this is the plot. I'm trying to have the video done by having this camera on like this, so I'll try to see if we can cover the whole plot and I can show you the plot. Okay, so this part is the x-axis and this is the y-axis, and on the right side you're gonna have your Km. On the left side you'll have your CP desired and your CP measured. Yeah, and this is the orbs that shows the population, how similar to the population data it is. Yeah, so you have all the orbs. You have the center of the orb here, it goes up until the end up there, and this will be the y-axis is actually your Vm, the maximum rate of metabolism, and also it also shows the dose rate, which is in milligram kilo per day. All right, and your x-axis is in milligram per liter. Okay, so say for example we have one question where your patient is 33-year-old and he's 68 kilos and he's on say 150 milligram capsule Phenytoin 3 times a day, which is 450 milligrams per day, right? So first of all, when you have the dose, then you need to have one steady state level which is measured. So in this case, on a 450 milligram per day dose, the patient's C trough is 18 milligram per liter. 18 milligram per liter, yeah, right? So first information you have is the dose, and the second you have is the CP measured. Yeah, you have the CSS measured already. So you can actually already plot one line because you already have one point for the x-axis and 1 point for the y-axis. Okay, but before you plot the dose on the y-axis, because the y-axis is the axis where you plot your dose. Okay, when you're plotting a dose, you have to make sure that you convert your total dose into pure Phenytoin. Okay, the 450 milligram that you have is also including the salts, so you have to actually know the salt factor for Phenytoin, which is when you are using an IV or you're using a capsule, then it's 0.92. So if you're having 450 milligram of dose, then what you need to do is times the 450 milligram with 0.92. Then you'll get the exact Phenytoin, pure Phenytoin level. That's where you have to put the dose in, yeah, on this y-axis. So if you take 450 milligram times with 0.92, you'll get 414 milligram. Okay, now, but as you see, the y-axis is not just on milligram per day, it is milligram per kilo per day. So you have to even further divide it with the kilograms to get the measurement of milligram per kilo per day. So if 414, the pure Phenytoin level just now, divided by the weight of the patient, which is 68, you'll get 6.09 milligram per kilo per day. So in this case, we're just going to use 6, yeah? All right, so let's plot our first dot here. Right, let's get started. You already have one point. Okay, the first point is your Vm, which is 6. Yeah, so let's see, this is your Vm graph and you're going to go 6 on the y-axis. So your plot is here. Yeah, Okay, your point is here. So this is where I'm gonna put 1x. This is our first point, yeah. Okay, that's your first point. And then you have your CSS measured, a steady state level that is measured, and this dose, which is 18 milligram per liter. Okay, so ignore the negative part here, yeah, but we are just gonna find 18 here, yeah. So you have CP in milligram per liter, so 15, 16, 17, 18, yeah. There is this, that is your second point, yeah. So your first point and your second point. Do you see it in the picture? Yeah, right. Now I'm gonna make a straight line crossing these two. Okay, just give me a minute, yeah. All right. Okay, now you get a straight line. You see your two plots, 2 points, and how we make a straight line out of it. Okay, so when you make a straight line and the line intersects more than one orbs, then the innermost orb is selected, and the midpoint within the orbit is found and marked as the middle point, and that's another point for us. Okay, so we're gonna take which is the midpoint for this orb. Okay, so how do we find the midpoint? Is by measuring. Yeah, by measuring, yeah. Okay, so let's see here. We're gonna look carefully. You're gonna put your ruler here and see how lengthy this line is within the orb, yeah. So you have 1 cm, 2 cm, and you have like 2.1, 2.2, 2.3, and that's like 2.4. Yeah, so you have like 2.4 cm here. 2.4 cm, so half of 2.4 cm will be 1.2, right? 1.2. So you have your midpoint here at 1.1, 1.2. This is your midpoint. Okay, so it's 1.2 here and 1.2 here. All right, so you got your midpoint. So this is your point number 3. I'll just make an X here. Okay, there are some students of mine who actually think that the center of the orbit, the ready-made center of the orbit, is the point that we were looking for km and Vmax. But logically, if the point is already given and you do not even have to draw it, then what's the point of drawing and finding all this information and plotting this whole line, right? So the dot is there, but that's just the center of the orbit. But you still have to find this midpoint in the orbit by using your line. So ignore this line, it is just to confuse you. So please do not get confused with this dot. But the dot that we are looking for is the one that we just plotted, which is the third point for this graph. So from this third point, which is the very essential point, now you get two informations. First, when you bring it down here, you'll get your km. Okay, so we're just gonna bring it, make a dashed line here. That's your dashed line. So what is this? This is a 1, 2, 3, 4. So this is like 4.5. Yeah, this is 4.5. So you can see your km is 4.5 milligram per liter. Alright, so you already have your km. Km is the substrate concentration when the rate of metabolism is half. When the maximum rate of metabolism is half. Yeah, Vmax divided by 2 is your km. Okay, and from this line again, you also can get your Vmax. So let's plot this on our y-axis. Can you see it? Yeah, right. I'm gonna do it like this so that you can see it. So this one, just make a dashed line, or you can just make a straight line. This is just very close. Yeah, so this is where your Vmax is, and your Vmax falls onto okay, let's see the scale here, because you cannot see the scale here. So this is 6, this is 7, 7.5 and 8. Okay, so your Vmax here is 7.5. yeah, this is 7.5. This is the line. Yeah, can you see the line? Okay, sorry. This is 6, 7, 7.5. yeah, which is this parallel with this dot that we have here, with this line. So your Vmax is 7.5 milligram per kilo per day. Yeah, that's your Vmax that you get, and you already have your km. So you have already obtained from 3 dots. We have already obtained our 2 very important information, which is our Vmax and our km. So if we are using any equation where we need a individualized Vmax and km for the patient, then we can actually find it this way. Okay, now what the next thing you have to do is you want to know what is the dose for another CP desired. Say like 18 is too much, because phenytoin therapeutic range is 10 to 20, and you don't want to hit that hard, and you want the CP desired to be only, say, 15. Okay, maybe there is some inhibitor drugs that can actually increase the level of the phenytoin in the body, phenytoin free fraction or the phenytoin bonded fraction in the body, in the blood. So you want to not hit so hard, and you want to keep the therapeutic range within a average of middle average, which is 15, say. Yeah, so you can have your CP desired 15 plotted here. Okay, so let's see how we get a dose from this method. Okay, so you see your CP desired is 15, so you have another plot here, another point here. Okay, so we already have 1 point, 2 point, 3 points, 1 point, 2 point, 3 point, and now this is our 4th point. Yeah, okay, so this 4th point is our CP desired. This is what we want to have in our blood. Okay, the level of phenytoin that we want to have in our blood. Okay, so from this, now you have you can connect this CP desired with this plot, this midpoint of our orbits. Okay, connect this with this. Okay, this level here. Okay, so let's connect it and see. Then from this line that you're going to make, you'll find that the intercept of the line at the y-axis will give you the dose for this patient. Okay, let's see. Yeah, so what we're gonna do is we're gonna join this. Yeah, I'll just join it outside the camera. Yeah, there you go. There you find the intersection. This is our, okay, this was 1, 2, 3, 4th point. This is our 5th point. Okay, so the y-axis, so what we have to do is see what this level shows on a parallel dose line. Yeah, okay, so we're gonna put this here and try to try to make it dash line that side. Yeah, this is just like a bit over the darkened line. Okay, just give me a second, I'll just draw this. Alright, there we go. I'll show you in the camera in a while. Yeah, there you go. Yeah, you see the line that we have. This is the dose. Yeah, dose milligram per kilo per day. So what is the dose here like? Okay, this is 4. So this is 4.5, 5.5, 5.5, and this is like 5 point, it's not 5.75, it's 5.7. Right, this is like 5.7. So the new dose you have is 5.7 milligram per kilo per day, right? But 5.7 milligram per day is the pure phenytoin, yeah? So now we are going to do it the reverse way. Okay, now we already have the dose. What we're going to do is times it with 68 first. Yeah, I'll just do it here so that's easier. Okay, we'll time it with 68. Okay, let me have the calculator. Just hold on. Okay, hold on. Okay, we have the calculator. Sorry, I'm using my phone, so I cannot have my calculator from the phone, so I'm just going to use the calculator here. So we're going to use 5.7 times 68, yeah, 68. So you get 387. Okay, this is what you get. You get 387.6 milligram per day. Okay, again, this is still your pure phenytoin. So you have to now divide it with 0.92 to get your salted phenytoin, yeah? To get your salted phenytoin level. Alright, just show me this one. Let's stay here, alright? Okay, so we are going to divide this. Here's my division. Divide this with 0.92. So you have 387.6 divide by 0.92. You'll get 421.3 milligram. So this is your dose for phenytoin that you require. Alright, just hold on. I'll show you the calculation. Alright, so do you see the calculation? 5.7 milligram per kilo per day times 68, you get 387.6 milligram per day. Divide by 0.92 and you get 421.3 milligram. That's your new dose. But again, you have to round it up to something suitable to give to your patient, right? You have to give it like, say, 400, or so if you're planning to give 400 milligram to your patients, because phenytoin comes in a capsule of 100 milligram as well, so it is doable. So you can give 400 milligrams per day to patient. So you might want to give 400 milligrams. So you can actually draw another plot from this. Yeah, if you're planning to give 400 milligrams, okay, see, you're rounding it up to 400 milligrams, then you have to again repeat the same process of converting this milligram per day into milligram per kilo per day, and also having it as a pure form. Yeah, so you will be doing it again as the first step earlier. So this is, say, what you want to give to the patient. Yeah, this is, say, 400 milligram what you want to give to the patient, and you want to divide it with your first, this 400 milligram you have to divide times with your salt factor. Okay, so now you're going to do it the other way around. So you have your 400 400 divide times by your 0.92. So you get 368. Yeah, this is what you get. 368. This is your graph here. 368 milligram per day, and you have to divide it. This is the pure form. Yeah, this is the pure form, and then you have to divide it by your weight. Yeah, divide it by your weight. So the weight here you have is divided by 68. Yeah, so 368 divided by 68, and you get 5.41. Yeah, so then you get 5. We're gonna have this here, 5.41 milligram per kilo per day. Yeah, so now you have 5.41 milligram per kilo per day. You already have this plot. You have your rounded up plot from this level now. From this level, you can actually find what is the expected CP that you're gonna get from your machine, or from what is to be expected in the blood when you use this rounded dose. Okay, so you're gonna draw another third line now. Yeah. Right. So let's get going. All right. We have our dose. So just hold on. All right. Yeah, there we go. Okay, so now we have 5.41, so we can plot it on this y-axis. Yeah, okay, so let's see where is 5.41, or let's say 5.4 to have it much easier to be plotted. Yeah, because we don't have the very mini scales here. So this is the line for 4. You have the line for, this is 4, this is 5, 5.5, so it should be somewhere here. Yeah, it should be somewhere here. All right, so we're gonna just plot this graph. This is our graph. This is 4. Close. Yeah. Okay, so this is 4, this is 5, and 5.4. Yeah, 5.4. So somewhere here. So I'm just gonna put a dot there. Yeah. Sorry. Just gonna put a dot there. Small dot there. Yeah. Alright, there you go. There you have your dot here. Alright, so you have the 5.4 milligram per kilo per day. Plot there, and then now you're gonna make a line using this dot on y-axis and your midpoint of the line in the orbit, in the middle orbit, and see where it intersects at the x-axis. Yeah, all right. Let's make that line. All right. There you go. That's what you get. Okay, when you round it up from 421, just now we had the dose that we get for CPSS 15. CPSS 15 was 421. Yeah, then we rounded it up to 400 milligram per day here, like this. And then when we put it on the Vozeh graph, what you get is an intersection at 11. Yeah, it's almost at 11. Yeah, this is your 11 milligram per liter. So when you reduce or round a dose, you will have some implication in terms of your CP desired. But because this 11 milligram per liter is still within the therapeutic range, then it is still acceptable. Okay, so this is your 11 milligram per liter. All right. Okay, so I think that's it about how to make a Vozeh plot. Okay, I hope you have learned from this short video. I am sorry for the for not getting to cover the whole plot in the camera, but I hope everybody learned from it. This is dedicated especially for my clinical pharmacokinetic students. Okay, all the best for your exams. Thank you.